Welcome to my channel. We are doing problems from the NCERT text on physics channel. So today we are with a new problem, which is a ball is throwing into air, and what will be the acceleration and what will be the other things we have to find from this question. So the problem is a player throws a ball upwards with an initial speed of 20.9 meters per second. So what is the direction of acceleration? The first question is, what is the direction of acceleration during the upward motion of the ball? The thing is, when in his hand, it has no velocity. So when he throws that ball into upward, the acceleration is zero because there is only velocity. Velocity is providing the ball to go up, and the only acceleration is available on that ball is acceleration due to gravity. That is in the direction opposite of the ball's movement. Ball going in the upward direction. The only acceleration is there is acceleration vector is acceleration due to gravity. Acceleration due to gravity. It is represented by G, and its direction is always towards the center of Earth. Center of Earth. So okay, so that's the only thing. That's the result of that's the answer of the first question. Then second question. What are the velocity acceleration of the ball at the highest point of its motion? When it reaches the highest position, the ball reaches its maximum height, there will be zero velocity. That is, it will not go up. At that point, the velocity is zero, and we can say the velocity of the ball at the top of that maximum point, highest point of the ball's track is their velocity zero at that point. Okay, and the acceleration, we already told that acceleration of the ball present in the balls available on the ball is only acceleration due to gravity. There is no change in the acceleration. That acceleration is always toward the opposite direction. That is the force present in the ball, only force. When the ball just come out of his hand, there is no force. The only force the ball have is the Earth's acceleration, Earth's gravitational force. So the acceleration is 9.8 and the velocity is 0 meter per second at the highest point. The question C is a little bit lengthy, and I will talk that in the next video. So we will do with the problem section D. To what height does the ball rise, and after how long does the ball return to the player's hand? Okay, this is a good question. This is actually using some kinematic equations, and first of all we have to find how much distance is go. First of all we find the distance. So how high did it go, and from that we can get the time. Okay, so we have an equation, V is equal to U plus AT. It's a kinematic equation. We can apply this equation here. So this way we get the answers. Use the equation we studied, then using what we have to find first of all. So what is the height? What is the height? Okay, so height, in order to get height we have to get the time. The time and velocity gives the height. So from here we can get the t. We have three known quantities. V initial velocity is final velocity is 0. Initial velocity u is 29.4 meters per second. And a, the only acceleration present here is g. That is the gravitational due to acceleration due to the gravity of Earth. And we have to understand that a is opposite direction of the velocity, and putting all these quantities in the equation we get 0 is equal to 29.4 plus 9.8 into t. So rearranging, this is negative actually, it's the opposite direction, so negative will come here, and 29.4 will go across that equation sign. Then 29.4 minus 29.4 equal to 9.8 times t. So 9.8 times 3 is actually 29.4. So 3 is here, and this minus minus cancels. The time we get is 3 seconds. This is only one part of the solution. Okay, first then we have to get the distance. So distance traveled, we have to find the distance traveled. So we have time, initial velocity, final velocity, and acceleration. So we have another kinematic equation, that is distance traveled x equal to ut plus half at square. So if we apply this, that x is given by 29.4 times 3 plus 1 by 2 into 9.8 into 3 square. So we will get 3 into 20, 3 into 30 means 90. So 1.2 will be decreased from 90, that is 88, 1.8, sorry, 3 into 0.4 means 0.6 actually. 13 means 3 into 30 means 90. So 3 into 0.6 means 3 into 0.6, no, 1.8. So 90 minus 1.8 equal to 88.2. This is the way we speed up the question problem solving. And the next is 4.9 into this. We can say this thing cuts 4.9 into 3 square. 3 square means 9. So 4.9 into 5. 4.9 into 9. This gives 5 into 10 means 45. And okay, we are cleaning all these things, and we have no place for do things. Okay. So what the x is 132.3 meter, and we have to find the time needed for the ball to come from this point, highest point, to this hand. This hand is taken as 0. This is the position. So we have some equation is there, the equation of kinematic equation, that x equal to ut plus half at square. So here we apply one more time we apply. So here x is 132, this highest point, 0.3, and ut means the velocity at which the ball trying to come back. At the two part is there. One is ball coming from the sand to the highest point, and then the highest point is sand. When considering the highest point, the velocity of the ball is 0. That is at that scenario, at that point, we take u is equal to 0 velocity, 0 meter per second. In this case, these are two cases. So that 2 adds to the complete picture of the problem. So 0 into t plus, and here half at square. In this direction, for the second part, the acceleration is positive. So 9.8 into t square we have to find. So here, so I will write here, okay, 132.3 equal to 4.9. These two cancel, and 4.9 times t square. So 4.9 is actually a multiple. 132 is actually a multiple of 4.9, and we both two will cancel and we get 27 times. T square is equal to 27. So t is given by, it is nearly 5.2 seconds, which is already I have done the problem. And the final answer for the total time taken is 3 seconds needed. We already find that t second for the initial time, and 3 seconds plus 5.7, 8.7 is the total time taken. And is C has some, we will look on this problem. Choose x equal to 0 at t equal to 0 to be the location of time and ball at. This is actually easy, but we will look on that because we need to take into some different pictures, and we will do that. Hello guys, we are back in the problem number 6. But in the C section, I already explained the A, B, and D. But the C, it was something bit different. It needed some graph, and I didn't explain that. So let us talk about that problem. That C, choose x equal to 0 and t is equal to 0 second to be location and time of the ball at its highest point. Vertically downward direction is to be positive direction of x-axis, and give the signs of position, velocity, and acceleration of the ball during upward and downward motion. So there's a question is about balls. Balls upward and downward motion are is explained here. So we have to put that into a graph, and we have to say the position, the velocity, and the acceleration of the ball is positive or negative. They are giving us the reference, and what is a reference diagram in which the negative direction, the downward direction is to be positive direction of the x-axis. That is the only thing we have to remind, and I will draw that. Okay, so normally we have XT graph like this. In the t will be in the x-axis and position in the y-axis, and this will increase. Position will increase in direction of x-axis. So here it is taking, say, the question forcing us to take like this. Time is same, but x direction is in the opposite direction. That the vertical downward direction, that is direction, is taken to be the positive direction of x. So downward direction is taken as positive. Normally downward direction is negative. You can say that it is negative direction. But here we have to take that this x direction, this downward direction is to be positive x. So this is the diagram we need. This is the graph. We have to put all things into this graph and understand. And we have to say the velocity, the direction, and acceleration of the ball to be set in terms of this graph. So this is the reference diagram. This is not on. Ordinarily normally we take like this, but we have to take like this. So I will erase this and okay, and I will explain the next things. So in the upward motion, the ball is normally in the reference is here. We can say that the ball actually is in the not zero. It's actually in the x position is around some values, positive value at the normal position, and after some time it will reduce to some this position. So this for example take this 30 meter and this is 20. So when it is upward motion that uh, the distance is decreasing with time, and finally it come into this point, that is highest point is 0 0 x0 t0, or somewhat like this, like something like this. We can also approximate like this because time is going. This is 30 minus 2, 30, 20 minus 1 and 0 0. So we can say that decreasing position, decrease in position, negative uh, value in position change with respect to time means the velocity is negative, and the position's position also negative. But we can understand from that the gravitational force, acceleration due to gravity, the acceleration is always in the positive direction. So there is no change in that. That is positive direction. So this is the upward motion's understanding, meaning of, and with respect to this kind of axis, and positive direction is taken in the downward side. In the other hand, okay, for downward motion, that from the ball is at its highest point and trying to come back. We can say that the x is at 0 0, and after some times it becomes 10 0, 10 0, 10 any kind of value t, and 20 0 and 30 0. That means position is changing in the positive. The position is positive. Position is began to take positive quantity, and change in position is with respect to time is also positive. That is velocity. And acceleration is not at all changing, and that direction is always positive. From here we can understand that the gravity always in the positive direction. This is the answer of the third C section. Actually, it is somewhat not at all understanding at first, but we can understand it. It's also all about taking the graph. What it's all about taking which part we are creating the graph. Actually, we can take graph from here or here. Why all references are made by the answerer. Actually, the people doing it. And as per the mathematics, we cannot make bad illogical answers. All answers are correct with respect to the reference we taking. So I think it is about mathematics, and don't worry about all the things. This is very easy, and I think little more difficult for the first time, but easy. Try your and thanks.